My PhD thesis was financed by the Synapse project. The main goal was to endorse an holistic approach to reproduce the earthquake phenomenon from the source to the site. The idea was to reproduce the whole earthquake in a huge computational model that encompasses the seismic source, E, the propagation path, P, and the nonlinear side effects, G, that takes place at the very uppermost part of the Earth crust. The final goal was to produce realistic broadband earthquake ground motion synthetics to be provided to the structural engineers for the seismic design of nuclear reactors and other facilities. During my PhD thesis, I have faced a multi-scale and multidimensional problem as an earthquake. Therefore, I've been firstly focusing on the earthquake observation and recordings at the downhole scale, at the site scale. Then, in the second phase, I have studied the seismic response of the Kashiwazaki-Kariwa nuclear power plant in Japan during the Niigata-Chuetsu-Orki earthquake of 2007. And finally, I've been reproducing the latter earthquake at the regional scale by developing a multi-tool computational platform able to reproduce the source-to-site wave propagation in the Earth crust. One of the major tasks was to assess the role of the complex geological structure striking right underneath the Kashiwazaki-Kariwa nuclear power plant, and to assess its influence on the final site response, so to improve the ground motion modeling and prediction, as well as reducing the misfit compared to the earthquake recordings. The geological model was constructed starting from 1D and 3D models obtained by previous geological surveys. Finally, the model was calibrated by running aftershock simulations and at different locations, so to be able to see and to assess the different response of the site when the source and the site have different relative position. One of the major findings of my thesis was the comparisons between the layered geology model and the folded geology model. The observation unveiled a strong amplification at Unit 1 that the layered geology model was incapable of reproducing. Therefore, the introduction of the foldings improved the ground motion prediction at Unit 1, and the seismic response obtained numerically was close to the observation. On the left is clear the poor fit of the synthetics when the layered geology is considered compared to the earthquake observation. On the right, we can see the improved earthquake ground motion prediction when we consider the folding.